right, today we're going to be talking about similar figures. Similar figures correspond a lot with proportions for various reasons that you're going to discover as we go through the lesson. Um, but first of all, we have some different words that we need to address before we even begin. So, as you can see on our slide here, it says, are these triangles congruent? And spelled wrong. There should be an R there. Congruent means equal to. All right. So what we can do is we have two ways of discovering that. In order to discover if a triangle is congruent, we need to know that the angles are the same in both figures, and that the sides are the same. Okay. So are they similar? Well, we know that this right here is a right angle because it tells us with that square mark. But then we can look at the angle of this one and we can actually see it's 50 degrees. Over here, we can do the same thing and we can also say, oh, that one's 50 degrees. So it looks like our angles are congruent. But how about our sides? Well, it's fairly obvious just by looking at these two figures that the sides are not congruent. Okay. However, we can say that these two figures are similar. Okay, reason being, xy is going to correspond with AB, yz is going to correspond to BC, and xz is going to correspond to AC, just like they're written down here. All right, now this setup looks a lot like a proportion, and that's exactly what it is. This is actually telling us that if our sides are proportional, okay, then the figures are similar, as long as they have the same angles as well. Okay, the angles always have to be congruent. All right, so the official definition of a similar figure is two figures are similar if the proportion of the lengths of their corresponding sides are equal and their corresponding angles are congruent. Okay, it's very important that you remember the corresponding part. Okay, all right, so let's do an example with this. They're asking, is rectangle LMNO similar to rectangle HIJK? Explain why or why not. All right, so in order to determine this, the first question we need to ask is, are my angles congruent? Well, yes, because every angle in a rectangle is a right angle, so we can definitely safely assume that all of the angles in this rectangle are 90 degrees. Otherwise, it would not be called a rectangle. All right, next, I can take two of my sides and create a proportion. So I'm going to take side LM and side HI, and I'm going to create a proportion. I'm going to go 10 corresponds to 8. And I'm going to set that equal to another two sides. I'm going to do it to MN, 4, and IJ, 3. And then I'm going to write 4 over 3. Now, one thing I want you to notice, when I'm setting up my proportion, just like what we talked about with proportions in the last video, we always want to stay consistent. So when we're working with similar figures, we want to make sure that the sides of the shape we're working with are across from each other. Just like 10 and 4 are part of the same rectangle, 8 and 3 are part of the same rectangle. All right, now I can use my cross products or cross multiplying to see if they are proportional. Well, 10 times 3 is 30. 8 times 4 is 32. Because these are not equal, they are not similar. Okay, they are not proportional, they are not similar. So our answer, no. It is not, the rectangles are not similar, and the reason why is they are not proportional. All right? All right, so um, using another reason we can use proportions in similar figures is when we know that two um, shapes, in this case triangles, are similar, it will be written like this. It's down here in this little bottom corner here. This one little squiggly line means similar to. So what this statement right here is saying is that triangle XYZ is similar to triangle ABC. All right, so we're looking at our corresponding sides, and we can actually set up a proportion of that. We can say, well, the side XY is 18, and the corresponding side AB is 6. My side YZ is 30. And BC, we don't know, so I'm just going to do X. So now, you know how to solve this using proportions and cross multiplying. We can immediately say, all right, well, I'm going to cross multiply, so I'm going to get 18x equals 30 times 6. So 18x is going to equal 180. Divide both sides by 18 using my inverse operations, which I'm sure you are all pros at by now. And figure out 180 divided by 18 is 10. All right, so my mystery angle right here is 10. Very self-explanatory. All right, now what if my shapes are overlapping? So it says some diagrams are going to contain figures that are overlapping. To solve those, we first need to separate the shapes into two individual figures. So as you can see, I have triangle CAB, and inside that I have triangle DEB. And I can actually take these two triangles and separate them. You won't be able to do something as cool and slick as I just did. However, you will be able to just redraw the figure from whatever problem you're working on, and that will make it a lot easier. All right, so from here, we can say in the figure at the left, we know that these two triangles are similar. It says it right here. They want me to find the value of x. So I'm going to set up a proportion. I'm going to say 24 corresponds with 16. And 18 from my first figure corresponds with x. Do my cross multiplying magic, and I'd like you to finish this problem for me in your whisk. Tell me what x equals in this overlapping shape. What is my mystery side going to be equal to? All right. The last example we're going to do today is a word problem. A lot of times we use, outside of just using similar shapes, like squares, rectangles, triangles, hexagons, whatever, um, we can actually use these in real life um, problem solving. So this next example is describing exactly that. So we have A model of a car is 7.5 inches long. The actual length of a car is 15 feet. The model height is 1.8. What is the car's actual height? All right, so I know my model car, which is my smaller run right here, is 7.5 inches. This guy over here is 15 feet. The height of my model car is 1.8 inches, and I need to figure out how tall my actual car is. Now, one of the first things you should notice right away is we have two different measurement units. We need to make sure that when we're setting up our proportions that we are only using one, okay? So I need to convert my 15 feet into inches. And to do that, I need to know how many inches are in a foot. And we know that 12 inches are obviously in a foot. So I can multiply 15 times 12 and get 180 inches. So now I can set up my proportion. I can say 180 corresponds with 7.5. And that my x, my unknown, corresponds with 1.8. From here, I can cross multiply and figure out how tall my actual height is. I'd also like you to finish this one in your whisk tonight. Pretty much that's all I have for you. It's very self-explanatory, similar figures, as well as setting up proportions for those similar figures to find unknown lengths. It's a very simple process once you have mastered the proportions and cross multiplying, which from seeing what you've been working on today, I can safely say that I think that you will do just fine with this particular lesson and you should not have a lot of problems with that. All right, so please let me know if you have any questions. Bring them in the next class. Otherwise, I'll see you guys then.